look at doing some of the 3.5 stuff. So the last piece of our chapter is going to be combining functions. And so how does that affect the domain of these functions and how do we evaluate them? So we'll take a look at number 12 since that one's not in the back of the book. First thing we're going to take a look at is going to be given a function of x and given a function g of x, we're going to determine the domain h of x of some new function that will be given as f minus g of x. So I actually like starting with the new function rule just to kind of see what's going on. So we're going to start with h of x, which this is part b. And we're going to see that this is going to equal f of x, 4x squared, minus 2x plus 3, minus g of x. Okay, so this is your f of x basically, and this is your g of x. And that really becomes our new rule. We can drop those brackets because I don't really have any common terms that I can combine. And so if we think about the domain of this, we want to think about the overlapping regions. So if I think about this domain, that's a quadratic. So we know it looks like a parabola, and its domain is all real numbers. I know that this, being a square root function, does have a limited domain. And again, I don't want any of that stuff underneath to be negative. So to find the domain of this function, we can take what's underneath and set it greater than or equal to 0 so that it's a non-negative number. We'll add 5 to both sides. We'll divide by 2. So we'll see that our domain is all x's that are greater than or equal to 5 halves. And so our overlapping region, since for f of x I can do anything I want, is really just this square root function. And so our new h of x domain, so part A of this question, is going to be all of our values that are greater than or equal to 5 halves, which in interval notation we can write as such. Okay, so there's our domain. Our new function rule is this, and because there's no like terms, I can basically just get rid of these brackets, and now we have our new function rule, h of x, and there we go. So we want to evaluate h of 7 and h of 2 if possible. First, let's look at h of 7. So h of 7 will be, just substitute 7 in for where all of our x's are. So 4 times 7 squared minus 2 times 7 plus 3 minus square root of 2 times 7 minus 5. Okay? So as we simplify this, we're going to see that this is 4 times 49, which is 196, minus 14 plus 3 minus the square root of 14 minus 5, so the square root of 9, which is 3. So we'll see that h of 7 is going to equal 182. Okay, cool. Just evaluate it the exact same way we've always evaluated stuff. Next, we can look at h of 2. Okay, as I go to plug in 2, hopefully we realize that that's less than what we said our domain would be, so it's not inside of our domain. And then as we evaluate it, yeah, it works great through the quadratic part, that originally f of x part, but because I can't take the square root of -1, 2 times 2 is 4, we can't take that square root of -1, this whole thing becomes a non-real solution. So h of 2 ends up having no real solutions, and so we can't evaluate it. Okay? So that's kind of the fundamental of what we're going to do. Next couple pieces I'll go through a little bit quicker, but we're going to basically be combining functions and trying to find the new domains for these. Next piece we're going to see, we'll start looking a little bit more than just addition and subtraction. Multiplication behaves very similar as well, just kind of looking at the overlapping regions. But then we're going to start looking at quotients of functions. And so hopefully something like 19 looks very familiar. We did it on a test recently. So our new h of x function here is going to be f of x divided by our g of x. And so when I want to find the new rule of this, and again, I'm going to start with my b part first because I like finding the rule first. We'll notice that the top can simplify out as x minus 4 times the quantity x plus 4. And so we see on top and bottom we have that x plus 4. So similar to that question on the test the other week, we end up with a whole, which is going to give us a limited domain. And so my new h of x rule is going to be as simple as what's remaining, which is just this x minus 4. But unlike the straight line x minus 4, it will not have an unlimited domain because I do not want to divide by 0. So I know that x cannot equal negative 4. Okay, so we'll double check. Top has all real numbers. Okay, it's a quadratic, so I've got all real numbers there. Check on the bottom, that's a straight line, all real numbers. So my overlapping region is all real numbers, but because of this division piece, my final domain is going to be all real numbers except for x equals negative 4. So x cannot equal negative 4, or if you express this in interval notation, you'd be able to say that negative infinity to negative 4 union with negative 4 to infinity, where we don't include that point negative 4. Okay? So that's what we're looking for these types of problems. You just want to be able to identify what that domain is, and again, because of the division, we don't want to divide by 0. We'll limit our domain by just that one point, in addition to our typical overlapping rules. So lastly, if we get this a little bit more complicated, we'll see that we'll end up with things that have limited domains as well as divisions. So if we look at our new r of x rule here, which is going to be written as p of x over q of x, that's our new function rule. I can't really simplify that, so that's fine. Again, we can look at our domains to find the overlapping. So on top, we got all real numbers. On the bottom, this is our square root function, so I want to take that stuff and make it non-negative. So I know that negative 2 minus x has to be greater than or equal to 0. If I add x to both sides, I'll see that x needs to be less than or equal to a negative 2. That becomes my domain. Overlapping region then is the x is less than or equal to 2. But in addition, I want to make sure that I'm not dividing by 0. So I know this square root of negative 2 minus x cannot equal 0 either. And so in this case, we see that x cannot equal negative 2. And so that adds to this domain where I'm not going to actually even be equal to. Okay, so when I combine those two pieces together, our final domain for this new rule r of x is going to be all of our values that are less than or equal or less than negative 2. So we will not include negative 2 in that domain. Because not only do I want to be less than or equal to because of the radical, I also don't want to be equal to because of the division. Okay. Last piece I want us to take a look at is if we get in a situation where you had two square roots. So let's say we had like the square root of x plus 2, and we had the square root of 8 minus x. And this is my g of x, and this is my f of x. And since we haven't done a multiplication one yet, let's say my new h of x rule is going to be given as, oops, given as f times g of x. Okay, so I'm going to multiply these together. So we'll end up with our new function rule being the square root of x plus 2, that quantity, times the square root of 8 minus x. That's as simple as we need to go as far as combining those. You could kind of multiply stuff inside, but it's not going to help us out a lot. So this is fine as far as the new function rule. So let's take a look at how this domain works. The first domain, again, it's a square root, so we want that part to be greater than or equal to 0. So we'll see for this piece, I want x to be greater than or equal to negative 2. In this particular piece here, same idea with the square root. I don't want this 8 minus x to be negative, so it's got to be greater than or equal to 0. And so in this case, we'll add the x over. We'll see that x needs to be less than or equal to 8. Okay? And so let's also just look at this graphically real quick so we see kind of what's going on. I know that this is a square root function shifted 2 units, go in that direction, and I know that this one is shifted 8 units, go in that direction. And so if we see visually what our overlapping region looks like, it's between these 2 points. And so I want that as my domain. And we can see that clearly through the graph, and we can see that with these 2 domains, the overlapping region is where they're stuck in between each other. And so my final domain for this situation is going to be our x is an element of negative 2 to 8. And so there becomes our new domain. Hopefully this will help make some of the sense of this. For the most part, you're just doing a little bit of basic math, combining like terms if you can, or simplifying things top and bottom. And then we're looking at how do we overlap these domains, and dividing by 0 is not okay, so we need to get that whole or asymptote other. Good luck. Have a wonderful weekend.